Imagine waking up tomorrow, no lights, no phone, no Wi Fi, no fans, no hospitals, no internet. Our modern world would almost stop. That's how important electricity is. But have you ever wondered what actually is electricity? Is electricity the same as voltage? Is current electricity? Or are they completely different? By the end of this video, you will understand all three concepts in a simple way. Let's begin. Everything starts with atoms. Atoms are tiny particles, right? It is made up of three main particles, which is protons, which is positive, neutrons, which is neutral, and electrons, which is negative. Okay, now in this electricity, electrons are the most important one, right? In materials like copper, some electrons can move freely. This is copper wire. There are electrons. It has some drift velocity. So this is electrons. These are called as free electrons. So what is electricity? Now imagine billions of free electrons inside a wire. They move randomly in all directions. They don't have one particular direction. They just move randomly equally in all the directions. So if they are moving randomly, they cancel out. So there is no actual useful flow. Now you have to connect a battery. Now what happens? Suddenly the battery causes the electrons to move in one direction. This organized movement of electric charge is called as the electricity. It is the movement of electric charge. That is called electricity. Electricity is the movement of charge, electric charge. In metal wires, this charge is carried by electrons. But what makes the electrons move? Why did the electrons suddenly start moving? Who pushed them? Imagine hundreds of cars are parked in a parking lot. Now what happens? The car won't move unless someone starts them. The electrons also needs a push. This push is the voltage. Voltage causes the push. It can be in form of battery or generator. So what is voltage? Imagine a water tank placed on a roof of a building. Water inside the tank has pressure because it is at a height. Higher the pressure, more is the height, more is the pressure, because P equals to rho GH. So if height is more, the pressure is also more, right? When you open the tap, like you're keeping a water tank on the roof of a building, when you open the tap, water flows. Similarly, this battery causes an electrical pressure. Instead of pushing the water, it pushes the electrons. So this electrical pressure is called the voltage. Voltage is measured in volt. It is measured in volt. That's why, have you heard of device like voltmeter? That is voltage, for measuring the voltage. Think of voltage as the force trying to move the electrons through a circuit. Greater the voltage, greater is the push. Next comes the current. Now we know voltage pushes the electrons. But what do we call the actual movement? Imagine opening a tap. Then imagine water starts flowing through the pipe. The amount of water flowing every second is similar to the current. Current is simply the flow of electric charge. That's all, okay? Simple as that. So voltage is the electrical pressure. Current is the flow of electric charge. So more the electrons passing through the wire every second, larger is the current. Current is measured in ampere or amps. Okay, so let's compare everything, okay? So imagine a water tank. The water pressure is the voltage. Flowing water is the current. The pipe is the wire, right? Battery is the water pump. Okay, so this is the basic of electrical circuit. If there is no pressure, no water flows. If there is no voltage, no current flows. So that's all about this video. So in the next video, we will answer another important question. If voltage pushes the electrons, what limits the current? The answer is resistance. And we will also learn one of the most famous equations in engineering, which is the Ohm's law. If you enjoyed this video, subscribe for more beginner-friendly electrical engineering content. Thanks for watching, and I will see you in the next one.